what we're up to in regional mapping within the Geological Survey. But look, firstly, I'm just going to put my GSA Governing Council hat on, and Paul's done a great job of mentioning some of the things with GSA that are happening. I just wanted to point out about the specialist groups because they've been incredibly active. This year we've seen the Coal Geology Group have a conference up in the Sydney Basin. We've had the SGGMP meet down in Benalla a couple of weeks ago, and the Tectonics and Structural Geology Group's about to have their conference in Denmark and Western Australia in a couple of weeks. So it's great to see all of these groups doing things. And also just Instagram, it's the only social media I do. It's a fabulous way to share photos of rocks and learn about the geology and landscapes across Australia. So just remember, if you're out on a field trip and you see something interesting, just to hashtag Geological Society of Australia. We've already heard about guests, and yeah, just it's a fantastic effort by the committee on how successful the planning is going for that, and I'm looking forward to coming down on the 10th and hearing about the research. There's also symposiums in Hobart, Adelaide and Brisbane this year as well. Sue wanted me to give a little plug for the Rocks, Landscapes and Resources of the Great Artesian Basin, new book by Warwick. The basin is in northern New South Wales, but mostly this will be about stuff in Queensland. And we've already heard about AGGC and the fact the first circular is out. And I was looking at the field trips, they look fantastic. So I'm looking forward to getting over to Adelaide next year. Now, with my Hedge hat on, I just want to say thanks to New South Wales Division for your support of Hedge. We've been meeting about 6 times a year in Newcastle now since 2008. Average about 40 people. This week, with Earth Science Week being about Earth and human activity, we had a talk on Aboriginal Earth and some of the use of natural resources and culture around the Newcastle and the Hunter area. So that was really interesting, actually, and you just realise how ignorant we are of the rich history from the Aborigines through our area. It is Earth Science Week, so happy Earth Science Week for 2017. It was started back in 1998 by the American Geoscience Institute. There's a couple of things that are happening across Australia. One is the AusRock Stocktake, which is the Australian Geoscience Council's second annual social media stocktake. So if you're into more social media things than I am, you can post your photos to Twitter, Facebook, LinkedIn or Instagram using that hashtag, and apparently some really cool prizes up for grabs. Sue's nodding, so it's good. And then the final one is Geological Survey is having an open day, actually open days. So this Friday and this Saturday, our office will be open up in Maitland for anyone who wants to come and see what we do, and there'll be some pretty cool rocks, minerals, fossils, etc. to look at, I'm sure, and some of our heritage maps, and some of our heritage people might be there too. So yeah, that'd be a really good couple of days.
Do we need to book for that, or is it just open
I think it's probably an Eventbrite page, but if you turned up, they're not going to turn you around. All right, so what I'm going to do is I'm just going to give you a bit of where we're mapping and why, and then a couple of run through our 2 main projects at the moment in regional mapping, which is East Riverina and Seamless, and then how everything we sort of do fits together and how you can use it, and then of course where to get this information. So you probably all think, oh well, the geology of New South Wales, don't we know it all? Well, we sort of know. We know some bits, but we argue a lot about other bits. And there's bits that we haven't mapped at a really good resolution. So this is the first geological map of New South Wales, probably. It's a map of the colony. So this is actually the coastline. You're looking west here, so north to south. So here's Sydney, and you can see what they mapped as the upper sandstone, which we now know as the Triassic sandstone we see through Sydney. That was in 1834. The Geological Survey itself started on the 1st of January 1875, and we've been moved around various government departments since that time. We're now within Department of Planning and Environment, which is fun. But that Geological Survey brand has been around for 140 years or so. This was the first geological map that the survey produced of New South Wales. So it took them 5 years to map the geology across the state. If you look at the 2009 sort of latest version, it hasn't really changed that much. There's lots of rock in the east.
What year was the first one?
it was 1880. And then still lots of rock in the east, but as you probably all know, as you go further west, we see lots of Quaternary and Cainozoic cover. We still stand on the shoulders of giants. This is the Edgeworth David map around Maitland from 1902. So our office actually sits just in here on the banks of the Hunter River. The subcrops and the structures that were mapped by Edgeworth David and others still, stood the test of time. It's just an amazing effort that they mapped so accurately, given the tools they had compared to the tools that we have today. We started mapping below the surface. I was back with Erwin Scheibner, who produced this stratigraphic map, and people before him, and Dick Glenn, sort of taking on these tectonic cycles and thinking about things in terms of extension and contraction. And it's sort of bandied around, but we do actually really have world-class geophysics across New South Wales. So the image on the left here, or your left, is the gravity across New South Wales, so looking at the density of rocks. This is the magnetic image of New South Wales, so you can see the Macquarie Arc here through the Genee Narromine Belt stands out because of the amount of magnetite in those mafic rocks. And here's an example of radiometrics out around Broken Hill, and you can see here's the Mundy Fault here north of Silverton, and you can see the high uranium granites being eroded out and onto the Mundy plain there. We do a lot of derived maps as well as geology maps, so I know they're a little bit hard to read, but this is the Broken Hill metallogenic map. We've produced a lot of regolith maps over the years. This one's up around Tibooburra, so looking at the provenance, so where did the materials that we see in the Quaternary systems erode from? In contrast, this is a geophysical geological interp map, so there's no outcrop basically on this sheet. Everything has been interpreted from below cover. We've been getting involved in renewable energy mapping, so mapping geothermal potential across the state. The other side of this map has got wind, tide, solar, etc., hydro maps. And then we, of course, use our maps for things like outreach. So this is a geology Broken Hill area here that's using some of the mapping from out there to help educate people on the geological history. So I guess when we decide where we're going to go mapping, we sort of have to think about, okay, well, what have we got and what are people interested in? So a couple of years ago, I put this map together, and it's looking at data confidence. So it's looking at the resolution of mapping versus the age of mapping. And there's nothing wrong with older mapping. It's just they didn't have the tools like geophysics, shrimp, whole rock geochemistry, the knowledge of biostratigraphy that we have today. And so the areas in the dark green are what we would consider our worst mapping, and that's a terrible word to apply to it. But that's first generation mapping that was done mostly in the 60s and 70s at 1 to 250,000 scale. Often those guys had 2 or 3 weeks to complete field work over, say 80 Ks by 40 K area. Clearly not enough time. We came along in the 90s and we started doing what we call second generation 1 to 250K scale maps, and you can see a few of these through here where there's a bit of geophysics kicking around, a few more tools to throw out the problems. In the mid-90s through to now, we've been mapping 1 to 100,000 scale. So here's Goulburn and Bathurst Dubbo, more recent map sheets out here around Cobar, north of Cobar, and the Coonambury Belt. But by far the best mapping we've got in the state is actually work that Barney was involved with. So the Broken Hill series that's been done at the highest resolution, 1 to 25,000 scale or so, and really has been a world-class mapping effort in there. And where we go mapping is really driven by, well, what do our stakeholders want? And our stakeholders are minerals and energy exploration. They're also water resources increasingly. They're also renewable energy increasingly. And they're also things like soils for agriculture, viticulture, forestry, etc. So at the moment, our main boots on the ground mapping, if you like, is down in what we call the East Riverina area. And I'll talk about that in a minute. This big green area is something we call the Thompson origin. That's about 15% of New South Wales. It's got about 1% outcrop. So most of the effort in there is involving geophysics and stratigraphic drilling. And then we've had some more recent detailed mapping around Captain's Flat and Braidwood, as I mentioned. We're also increasingly not just looking at the surface, we're trying to understand the crust. So we want to understand what we see on the surface, but we want to get a three-dimensional picture of what's happening below. And that's really critical for ore deposits. So we want to understand crustal architecture, heat, fluid, metal transfer. How did these things get into the upper crust? We want to understand the geodynamic history. And we're also doing a lot of work around cover. So the type and age and the depth of cover. I'll talk about that in a sec. We sort of follow, I guess we broadly follow the uncover themes, which was put forward by the Academy of Science, trying to understand 4D geodynamic evolution, metallogenesis and lithospheric architecture. And if you think about mineral systems, we're really looking at these big picture questions about what's the geodynamics, what's the architecture, how did fluids, or where did fluids come from that, and how did they get up into that upper crust and be deposited. Within the regional mapping team's got 9 of us, plus a couple of casuals and a graduate. We sit within Geoscience Acquisition and Synthesis, that's led by John Greenfield as director. So it's one unit within, of 4 units within the Geological Survey. You can see here we've also got a geophysics and modelling team, we've got a mineral systems team who look after the high logger, and we've got specialist services that support all our projects in terms of petrology, paleontology, geochemistry, etc. But whenever we do a project, we're very lucky to have this multidisciplinary approach. So this is from East Riverina. These are all the people who are involved from the survey in different guises. Jamie and Glenn, who recently left the survey, so we're structural metamorphic geologists. We work very closely with geochronologists at Geoscience Australia. We've been doing some postgrad research work with the University of Newcastle. We've had projects with CSIRO, Centre of Exploration Targeting, RMIT, with spectral studies. We work with our colleagues interstate, Ross down in Victoria. We also talk to landowners, and that's how we find out a lot of information about rock types, fossils. What do the councils want? What sort of construction materials are they after to build better roads or build flood defences or whatever it might be in their towns? So there's a lot of collaboration that goes on. When we're out mapping, we're using these tough pads, the Panasonic tough pads. You can see Steve carrying his around like a little cheese platter. We've got a little what we call field obs for data collection. So that's a Microsoft Access database that's synced back with SQL. We're running ARC on these things, so we know where we are. There's a lot of lookup lists that come into this so that we can control some of the values that go into the database. And you can record anything you want in terms of structure, lithology, samples, petrophysics, etc. And the beauty of it is that all of that field obs information gets delivered through the GDW, which anyone can hop on and look at. So you can go and click any of these little dots across New South Wales. There's about 120,000 of them, I think, at the moment. Still getting some of our legacy data into that system. Zoom in Google Earth, click on a dot, and you can see observations and measurements that were made by people in the Geological Survey and see field photos, etc. from that site. Just looking at what's next, I suppose we are responding to the minerals industry in a way that Narromine is a sheet that has a lot of metallic mineral potential, and that's somewhere we'll be mapping in the future, as will be the margins around the Cobar Basin, and also Gilgandra, where the Macquarie Arc is interpreted to dive off underneath cover. But we've put in a proposal to be involved with this MinEx CRC. It's only a proposal at this stage. One part of that is called the National Drilling Initiative. If that gets up, we'll be drilling about 700 stratigraphic holes across New South Wales over the next 10 years in areas of undercover. It's going to be probably the most fantastic deluge of data and opportunity for research. So yeah, we should know about that by April next year. Okay, East Riverina. So where is it? It's this little area here in the central Lachlan origin. If we zoom in a little bit, here's West Wyalong. Wagga sits in about here, and here's Albury, and here's the border with Victoria, which is the Murray River, of course. Geologically, most of the belt is the Wagga-Omeo metamorphic zone. You've got the Gilmore fault zone, not named after me, but I'll take it. There's a little locality of Gilmore down here just near Adelong. It's nothing. The only feature there is an agricultural hall, so it's a bit disappointing when you go. But anyway, I digress. You've got the Tumut Trough across to the east. Got the southern part of the Junee Narromine Belt, it's part of the Macquarie Arc, and then over on the east we've got the Cancuna Fault System, which, when you go into Victoria, of course, we have to call things different things. It's known as the Kiewa Fault Zone, and it separates the Omeo Zone from the Melbourne Zone. If you're familiar with Victorian geology. So it's a pretty big area. We've been mapping here for 4 years now. I've got about a year to go. You can see all the dots on here are places that we've been. It's probably about 20,000 field obs, I think, so far. This sort of gives you a bit of an idea too that the next year will be concentrated down in this area where there's still a lot of outcrop to be done. And the reason we're there is most of the mapping was done back in the 60s and 70s. Pretty coarse scale, 1 to 250K. We're mapping at about 1 to 100,000 scale. And it was pre-high quality geophysics and shrimp and things like that.
What are the different colours of the document?
Just different geologists. Yep. Don't know. I won't tell you who's who. East Riverina is an interesting one. It's you all live in Sydney or surrounds, and you think, what land use pressures could they have down there compared to what you put up with in Sydney? But the Hume Highway corridor is actually really expanding. Wagga and Albury-Wodonga are starting to really grow as regional growth towns, plus the satellite towns around those are really taking off. And every time you hear about the inland freight or the high-speed rail, they pass right through this part of the world. And we realised that we didn't really have a good handle on the geology. We were getting land use referrals coming into the survey, asked to make comments on developments and what the impact would be on mineral resources, and we realised we didn't really have great information to be able to answer those. Of course, if you build things like inland high-speed rail, you're going to sterilise corridors, but you're also going to need construction materials. So there's opportunity here as well as challenges. There's also a lot of mineral endowment. The two main systems, I suppose, are tin, and I'll talk about that in a bit, and also porphyry, copper, gold, and epithermal systems, and I'll talk about that in a sec as well. There's some pretty major initiatives that East Riverina falls within. One is the South East Australia ARC linkage project that's being run out of UTAS. We, with Geoscience Australia, the Victorian Survey and the Tassie Survey are part of that, as is ANU, University of Melbourne, University of Newcastle, and around 10 companies. So although it's really focused on understanding the porphyry systems and the Macquarie Arc, they're also looking at geodynamic reconstructions, and where we're mapping here is sort of critical to understanding the geology through that part of the Lachlan origin. It's also a really good test bed for the big ideas. Just some of the cartoon drawings from the literature, so the Foster and Gray model, the Chris Ferguson model from 2009. You can see the red circle here is our project area. So, and then the Cayley and Musgrave model that's in prep. We're right in the guts of these models, so we can actually do some detail mapping and get some new data that will help support or maybe help enhance these models for understanding the Tasmanides geodynamic story. So looking at East Riverina, let's look at some rocks. The oldest rocks that we've got are the Ordovician turbidites. This is probably about the best road cut in about 200 k's by 200 k's on the Sturt Highway. You come into one of the darker bands here. Here's a little chert block that's probably about that big that was taken out. A thick section was made of that. And Ian Percival and Yongyi Zhen out at Londonderry are able to identify some conodonts. If you can identify these conodonts and they're diagnostic, you're getting about 1 million years resolution in the biostratigraphy. which is fantastic. If you think about shrimp ages, you usually plus or minus 2.5 million years or something. So you're getting a lot higher resolution from our fossils. So they're a really critical part of our mapping work. And so in the old mapping, all of the turbidites were just called Ordovician. We've been able to break that down now into a distinct early Ordovician package, a distinct middle Ordovician package, and then we see graptolite bearing black shales coming up in the late Ordovician. We've also got a series of younger basins from the Ordovician through to the Devonian. They've been a little bit more problematic because we're not finding fossils. We're trying to use detrital zircon provenance to constrain the ages and the source of material that are in those basins. Yeah, that's a bit hit or miss as well. The other thing we can do is look at the structure. So here's a beautiful angular unconformity here with these moderately to steep dipping conglomerates here, underlain or overlain by flat-lying quartz-rich sandstones at Square Knob, just now near Narrandera. So we really want to understand the structural deformation and the fabrics that we see in these basins and piece together their history. One reason that's important is a gold story. So Mark Eastlake was mapping up around Barmedman, got the Gilmore fault, got some lower order faults. He managed to work out his from his facings, he's got a big anticline in here. When he started to plot up the orientation of all the gold veins, came up with these beautiful orogenic settings here. So hanging wall anticlines and gold associated with faults coming off lower order structures. So there is an economic reason to understand the structure of these basins as well. When we started East Riverina, we didn't have too many age dates. The red dots actually were the existing. Now we've got all the blue dots. So there's about 60 new isotopic ages in this area, which is it's actually pretty insane when you step back and think about that. It's been very targeted. We've been doing the geochron after we get a handle on the geology, after we do mapping and petrography, so that we're not just throwing samples in willy-nilly. They're quite strategic where we've been sampling. Most of that uranium lead shrimp's been with Geoscience Australia. We've also got some laser ablation, some argon and hafnium oxygen that we're waiting for at the moment. And this is sort of an example of how things are changing. So the Cootamundra 250K sheet was put out in 1996. They didn't have the luxury of shrimp like we do now. So most of the magmatism was interpreted to be around 430. We now know that we've got all of these distinct magmatic events through time. And I'll talk about those next few slides. The first one is the extensions of the Macquarie Arc. So we've got these andesites that have been known in the Gidgibung-Tamora belt for some time. And in fact, if you just zoom in on that area, you can see all the gold and copper occurrences that have been intersected through there by drilling. We've been mapping down through here in what's called the Junawara volcanics. Some new ages come back, maybe a little bit younger than what you'd expect for phase 4 of the Macquarie Arc, but the ones are diorite, so certainly in that ballpark. The chemistry is looking pretty interesting as well. Mark's been mapping and identifying these silica pyrite caps, and we're just exploring at the moment whether there's any anomalous metals kicking around with those, and looking at whether we're looking at lithocaps over some sort of epithermal porphyry system, or whether we're just seeing some sort of exhalative horizons that are associated with mafic intermediate volcanism. Fortunately, you can't see the pyrite crystals that are in this silica pyrite cap. But this is an area, I suppose, a classic example of boots on the ground, walking over hills that nobody's looked at for probably 50 years or so. So we're now looking like we've got these porphyry copper gold moly, porphyry copper gold, high sulfidation epithermal carbonate based metal systems that continue down, possibly these lithocaps continuing down through this belt as well. So looking at one of Greg Corbett's cartoons, you can see we've got mineralised systems in quite a few of these sort of classic porphyry epithermal settings, which is great for explorers. The most voluminous rock we have are these dirty S-type granites, around 430 MA. So dirty because they have all these big sedimentary xenoliths. You can see a great example here coming in. We're sort of a little bit reliant on the seasons. If it's a good season and the canola is about this high, you've got no chance of finding these pavements and tors. It's been a bit dry down there, so unfortunately for the farmers, but good for us for finding good exposures. This is the new series of magmatic events we've been able to identify. So the light pink are intrusive phases, the dark pink are extrusive phases, and all around 423 to 414. And the sort of dogma through this area is, oh yeah, all the granites are 430. Well, clearly they're not. We're also getting these differing affinities between the IS and A type. So there's quite a complicated story there that we're just starting to hopefully unravel. And some photos of some of these 415 granites. So Burundana, this one on the left, is a really high level granite full of myrolitic cavities and tourmaline and a bit of cassiterite kicking around. Then if we go up to Colin Gully, pretty much the same age, just a classic S-type. We come down to Holbrook, we've got an I-type here with hornblende in it. It's also got some molly kicking around, a bit of copper. Follogalong down on the Murray, continuing into Victoria, is another 415. It might be an A-type. We just got some geochem coming back from that. Kiamba has got these beautiful big megacrystic K feldspars, an S-type, and the same up here at Yarranjerry. So whereas before our maps just showed, yep, everything's 430, there's clearly a lot more diversity through there. Kate Bull has been leading the volcanism story down here. So she's been able to identify these coherent lavas. So you can see some beautiful flow banding in the rhyolite sample here, and also a porphyritic, quartzpheric lava here from Wallaruby. They sort of contrast with these ignimbrite facies, and you can see class of country rock and also these crystal-rich facies of pyroclastic material that's been erupted, and a nice little tubular squashed pumice fragment here in one of these ignimbrites as well. There's also some pretty weird chemistry. So metaluminous amphibole is not something you see in volcanic rocks that often that I know of. So as I said, lots more to be done. Geochemistry, petrography, we've got isotopes coming back as well. We really want to understand why we've got different source materials providing different magmas at exactly the same time, and also stoping out granites from only about 15 million years earlier. One implication of this is the tin story. So before we started mapping, we got the Centre for Exploration Targeting over in WA to do a tin prospectivity study. And so the assumed knowledge, there's Ardleffen, which is the biggest tin occurrence that's known, about 66,000 tonnes of tin, about 40,000 tonnes sitting in a stockpile, just saying, mine me, or process me, actually. But the Victorian border is sort of in here. Now in the model, the prospectivity model, they basically had to assume that all of the granites were 430. Phil Blevin has long suspected that the tin was younger. And so it seems. So our 430 granite that hosts the mineralisation sits down here. The tin is coming in probably even a little bit younger than 412. So exploration companies have been out there looking at thinking all granites are the same. We can actually help them refine their exploration models now by saying, yeah, I probably wouldn't worry about looking at the 430 MA granites. I'd be looking at these younger granites as a source of, or as a good place to be looking for tin. So we're going to rerun that prospectivity model after we finish mapping with all the new information. And I think what we'll find is the exploration fairway will really be narrowed down as a result. So hopefully that means exploration companies will concentrate where they do their work and hopefully have a higher success rate of finding further tin resources. I'll just skip over that one. Down out of Albury is a big nested I-type, highly fractionated complex called the Jindera granite. They've never been age dated. The Chapel map has it as Silurian. They've actually come back and done about 6 age dates through here now, and they're all within error around 405. And in fact, if we zoom in, you can see, hopefully you can see these nested plutons. So here's the first pluton, the second pluton coming in and stoping it, and then this bigger third lobe coming in and stoping that out. All within error around 405 MA. There's also some rare earth element potential around this area, so that's something we're looking into at the moment. In terms of understanding the metamorphic history, that's obviously something we do routinely as part of our mapping. But we had Brad Williams, who was an honours student at the University of Newcastle, now on our graduate program, do some work around Holbrook. So he identified high temperature, low pressure fabric down here in the Wagga group. We knew there were contractual fabrics, but we've also got this early hot fabric that's developed. And he's put together a really useful guide for us in looking at the different fabrics that you'll see, whether you're in high strain or low strain rocks, and whether how close you are to that heat source. So that's been a really beneficial thing to help us understand the metamorphic environment that we're in. We've picked up a lot of new shear zones. So this is a myelinite zone. Mark's mapped up here at a place called Ellenvale. We've actually got argon results just coming in from that at the moment. That's a big splay off the Gilmore fault. So that's going to provide us timing on that sinistral movement you can see there in the S and C planes. And then down here at Galore Hill, Steve Trigg's been mapping and found a dextral myelinite zone through a granite, a 430 granite that continues through here. We've also had a student called Michael Bell at the University of Newcastle do argon at 6 locations up the Gilmore fault in different age packages of rocks, so that we can understand the deformation timing in those different packages. So when all that's put together, we're going to have a much better handle on the timing of movement on these major fault systems. Deepika up at the University of Newcastle has just finished her master's looking at potential field modelling along our deep crustal seismic lines. So understanding the geometry of structures and bodies in 3D. And Jamie Robinson and now Giovanni Spampatino, working with Bob Musgrave, are doing similar exercise, trying to understand that crustal framework, understand our fault geometries in 3Ds, and that's the fluid pathways to get these metal-bearing fluids up into the upper crust and heat as well. So I guess with the Gilmore fault zone, we're sort of trying to look at this thing holistically. We know it's a major long-lived crustal structure. There's magmatism for at least 100 million years. It's got multiple deformation events. It's got gold everywhere you see a dollar sign, but all different styles, some related to intrusion, some related to orogenic systems. So we're looking at just trying to think about this fault structure instead of sort of map sheet by map sheet, which has been a bit more of a survey approach, starting to look at it as a system and comparing it to things like the Boulder Lefroy, which controls a lot of gold mineralisation around Kalgoorlie, and also the D'Amico fault, which controls a lot of the porphyry mineralisation in northern Chile. And so this is the most schematic conceptual thing you've ever seen in your life. But it's looking northwest through the East Riverina area and just giving you a sense for the age of the different magmatic events and some of the mineralisation that's come in. So our 430 MA porphyry copper gold, our tin at around 412, orogenic gold sitting out here in splays off the Gilmore fault, and rare earth elements associated with some of those younger granites. And I think this is the last slide I've got for East Riverina, but one thing we've been doing for the last 3 years is having a booth at the Henty Machinery Field Days. So 50,000 people turn up each year. The amount of people who they know the geology of their farm because that's what they work with every day, but they don't sort of know what it means or how to explain it or how old the rocks are. And they'll come in and they'll go, oh yeah, geez, I find all these graptolites up in the back paddock. And you're like, your beauty will be there. So it's also just showing people the geology in 3D using the Geoscience Data Warehouse is amazing. Just being able to explain to them, well, that's where you're getting a lot of runoff and erosion, and that's because of the bedrock geology and the slope, and this is where you're going to get a pooling of water. It's been very beneficial for us, and I think the local communities, some of the local communities got a lot out of it as well. We always get put next to our government cousins from local land services. So some years you're next to the people trapping wild dogs. This year we were next to the people looking after biosecurity. So it's fascinating to see what other parts of the government do as well, and I'm sure they find what we do pretty interesting as well. Okay, seamless geology. So this is our other major project in regional mapping. It's been going for a few years now, and we're on the homeward stretch, sort of. The idea is to take all of the disparate map sheets that we've done over the years. So this is the coast here. It's the Queensland border, Victorian border. It's what we call Zone 56. Taking all these individual map sheets, getting rid of all of the mismatches across boundaries, between scale, between units, coming up with one stratigraphy, interpreting underneath cover. And the big difference with what we're doing to what other jurisdictions have done is we're in putting together a series of time slices based on geological provinces. So when you take all those disparate map sheets, you end up with a surface geology that looks like that, Zone 56. And we wrote a quarterly note a few years ago telling you how we do that. We've now got 3/4 of the state done, so we're busy working on what we call Zone 55 West at the moment. When that's done, for the first time, we'll have this seamless geology across New South Wales. It also provides a great base for value add in terms of things like fault attribution and metamorphic maps, and I'll show you that in just a sec. So this is how it works in terms of time, in terms of provinces, time slices. So this is Zone 54 now, so we've jumped across to Broken Hill and the South Australian border, the Victorian border. So here's, I think this all goes away again. Yeah, there we go. So the top layer here is the Quaternary and the Tertiary, so the Cainozoic sedimentary layer. If we strip that off, we've interpreted Mesozoic basins underneath that. So that's the Great Artesian Basin, the Eromanga Basin. You can buy that book that Warwick's written through the GSA. Sue will be happy to show you a copy, I'm sure. We can strip off the overlying geology and look at the Permian basins. We can just look at the Devonian basins. We've interpreted solid geology for the Delamerian, Thompson and Lachlan origins, and then the oldest rocks through this area, the Curnamona province. If we have a look at Broken Hill, this is outcrop of the Hawes Gneiss out on the Menindee Road, so that's the North mine you can see in the background. Now, Barney might recognise this. This is one of your publications. This is the Broken Hill 1 to 25,000 map. This is what it looks like. It's got lots of yellow for Quaternary. It's got lots of brown because that's Broken Hill. And the other colours are the lithology mapping of the outcrops through the area. So you can actually take off the man-made structures in the Quaternary, just look at the outcrops. Barney and Bill Reid put together a solid geology, so we can start to now look at where those outcrops of geology lie over the solid geology, and you start to see all these shear zones coming through and a bit more joining up of units. And then we can just take the outcrops off and just look at our solid geology intert below Broken Hill in the line of load. This seamless geology, we say we're going to complete. What we mean by that is we'll have stitched together the best available. We know there's always going to be issues, and we want your feedback. I think Chris has already provided some feedback, which is what we want. We want everyone to be using the best available geology in New South Wales, and as a community, we need to work together to get there. So once we hear from you about your issue, and you give us a bit of evidence of why you disagree, we'll add it to our register and we'll fix it and we'll release a new version. And we're also happy to incorporate thesis mapping where we know it's of high quality from the universities, some company mapping where we know the quality is good, and of course our future mapping will come into that. And John Greenfield likes to, his analogy is the Sydney Harbour Bridge. You start painting it, and when you finish painting it, it's time to start painting it again. And that's the sort of analogy for the seamless geology. It'll always be something that's it's being improved upon. In terms of value adding, we've produced a metamorphic map of Zone 56, so mapping the isograds as well as the facies through that. We're currently working on Zone 54 at the moment. That's a bit more challenging because we've got everything from the Alarian orogeny at around 1600 through to Tabarabran orogeny around 380, everything in between. We realised that a lot of our maps overemphasise the amount of outcrop. So if you look at Zone 56, again, this is the New England area. If you went there, you're not going to find as much outcrop as our maps show. So we married up soil information and also our field observation system to come up with a layer we call an outcrop layer, which we think represents where there's going to be rock. So you'd be pretty confident of going to one of those coloured polygons and seeing rock, whereas here it's a bit more of a shot in the dark. When you get the seamless geology, you can click on any of the polygons and you can see the name of the unit and you can see its parent and what group it's in. You can see a description of its lithology. You can see some information on its ages, so maximum, minimum ages, information on depositional environment, on the geochemistry. We're also building in things like fractionation, redox state for magmatic rocks. You can also link that back to stratigraphic unit tables. So instead of having to go through multiple volumes of explanatory notes or journals to find out the best information, there'll be a single point of truth for these stratigraphic unit tables. And eventually we'll link them up to things like measured sections and field photos as well. Fault attribution is actually fairly mind-blowing, and I can't wait for the whole state to get done. We've taken every fault, and in New England there's about 17,000. Taken the fault, put it into a fault system, looked at whether it's been mapped or it's been interpreted, some information on the geometry. So you can see here the dip angle, the length, also the depth. So this one's a lower crustal fault going down to 20 to 30 Ks, whether you can see it in geophysics data. But then we've been through and we've attributed the sense of movement in different tectonic cycles. So what it means is you can, for New England, you can pull out just the first order faults, so the big crustal fault. So here's the Pearl-Manning fault system through here. This is the Hunter-Mukai fault and the Demon fault, the major systems. You can look at those faults, the fault families if you like, but you can start to run these queries. So you can start to just in GIS say, right, I want to see all of the steep faults, the 20 to 30K deep, and we're active during the Hunter-Bowen extensional cycle. So this is really powerful for geodynamic reconstructions, but also for mineral exploration as well. Our 3D model, it's the bread and the filling. So we know about the surface geology. What we're trying to do is model that basement interface, if you like. They're the sort of key surfaces. Then within that, we can start to put in the key marker horizons and the major structures. And if we're lucky, we've got a drill hole that goes right down through the middle. We've been doing these 3D models across the state for a while at sort of province scale. So the Clarence Morton, Sydney Basin. I think that view, that's looking west. So again, north to south, and you can see the different key horizons through the Sydney Basin as we look west. Surat and Gunnedah. We've also worked at a regional scale, so understanding the Tamworth belt, looking at high logger data around the Cargo copper gold porphyry system, and working down in the East Riverina area as well. We've also got a depth to basement model. Now, what we call depth to basement is actually a combination of the thickness of the unconsolidated cover. So this is the Cainozoic sediment, so your Quaternary, alluvium and colluvium. Plus, we consider in the mineral space that Permo-Triassic basins like the Sydney Basin or Mesozoic basins like the Yarramanga are cover as well, because we're really interested in what's below them. So we've actually produced different depth models. That one will take you through just the unconsolidated cover, the second one that'll take you through the consolidated cover, and that gives you a true depth to basement. And here's a nice little example from the Coonaberry Belt that I think illustrates that. So here's our Neoproterozoic Kara Formation. These rocks are around 580 MA. You can see them pretty weathered, but they're steeply dipping down here in the creek. Somewhere around here is an unconformity up into the Eromanga Basin, so Mesozoic in age. Sitting on top of that is an air formation, which is tertiary or Paleogene, Neogene. And then right at the top, there's a little bit of Quaternary lag as well. And you've got a couple of geos sitting on the top there. So you can see that in this case, we're not just looking at the unconsolidated covers, just this tiny little bit on top. The consolidated cover is actually this Eromanga Basin sediment. So by adding those together, we can get a true depth basement in areas where we're lucky. Where we're unlucky and we don't have outcrop like this one. And that's the sort of image that you get. So the white areas are areas of basement, so pre-Permian geology. You can see the deepest parts of cover to basement in New South Wales are underneath the Sydney Gunnedah Basin. And you can also see, if you're a mineral explorer, you're looking at 500 metres tops really for cover for something that's going to be economic to mine eventually. So you start to get a feel for where are the explorable parts of New South Wales in terms of that cover thickness. Okay, I've got a little example here from here's Tamworth Narrabri Gunnedah, New England, just to show you how all this fits together. So that's just a topo map. If you go to the seamless geology, this is what you get. So you get Quaternary, you get the Cainozoic Igneous Province. This is New England geology. There's bits of Gunnedah Basin, and there's bits in green there, which are the Surat Basin. We can just take off the Quaternary and the younger igneous provinces, and you can see here's our Surat Basin. Let's get rid of that as well. Now we've just got the Permo-Triassic sitting out here, and the New England origin. Let's get rid of the Permo-Triassic, and here's our interpreted Lachlan New England interface. If we click on any of those polygons, we get basic information about the age, the parent group, the lithology. You can go a step further and find out everything you possibly want to know about that unit from the literature. If you click on the faults, you'll find out that that's part of the Peel-Manning fault system. It's a first order fault. During the tableland cycle, it was interpreted to be a reverse, and was also had reverse movement during the Hunter-Bowen contraction around 250, 260 MA. If we turn on our mineral occurrences, and this is the Nundle area that we're going to focus in on, we've actually done a 3D model here by Jamie Robinson. So again, here's our little gold occurrences around Nundle. Put on the geology. These are the actual vein orientations in 3D. And then the major structures through that area. And Jamie realised, well, we're sitting right in this releasing bend along the Peel-Manning fault system, and that really is controlling the orientation of all those gold veins. So there's not that many examples where everything fits together so nicely at the moment, but it's coming. So it's going to be very exciting to see that integration. Okay, and just to finish up, of course you go to our website. If you don't know about DIGS and GDW, I really suggest you have a look at them because they've both really been enhanced. Who's got New South Wales geology phone maps on their phone? You can see most, yeah, good. Well, it's the people who went to Broken Hill on the GSA trip. So they had 15 hours in a bus to learn how to use it. But this is free. You do need, it's good to have Wi-Fi to download the maps, but basically you can get any map that the survey's ever produced will be there on your phone, as well as some of our geophysics data sets. You can zoom around. It works using the GPS in your device, so you don't need mobile coverage. So this will literally work in the back of Burke. You can click on the screen when you've got geology and you'll get information about the unit that you're looking at. Also with the seamless geology, as you zoom in on your map, the level of geology will get more and more detailed, including structural points. It's actually phenomenal. I use it all the time. I actually use it more than my mapping tablet now, I think. And MinView is something you might have seen before, but this is also just recently been upgraded. And this is where you can come in and you can discover and download all of our data. And of course, it's all free, and we're all really happy to help you get the best data for what you're trying to do. Okay, thank you.
Thanks, Phil. Great talk. We've got a little bit of time for questions, Graham, straight into it. Going back to your very first map where you showed sort of the age of all the mapping, that your green to red, and the green I think was 250,000 older maps, not necessarily poorer quality, and that was the majority. Surprised first of all to see that the New England, except for one tiny little bit, was pretty well all green and old.
Yeah,
and
that's...
yet you're able to, when you're talking about your value add and everything, you're able to do a hell of a lot with that. Do you go back in those old green areas and in doing this seamless, actually go and enhance, update without actually going back and remapping? I mean, what's the...
Not at this stage of the seamless. This has really been about taking what we've got and getting it into that geodatabase. But we call it phase one. Phase, as I said, we've got an issues register. We know where there's problems, and that's really going to help us prioritise where we map in the future. But what I will say with New England, and great pickup, Graham.
I guess my underlying story is you had an office there for so bloody long. Why is it all
okay, I've lied to you slightly, or misled you slightly. This isn't showing the metallogenic mapping.
Oh, okay.
And this is just looking at geological mapping. So that area is, we'll get there. By the time we get there, I'll have answered the question, hopefully. But yeah, so there has been enhancements to the metallogenic mapping. Now, the other big thing in the seamless geology is the thesis mapping that's come out of University of New England. And there's some fantastic mapping that's been done in that part of the world. So yes, a little bit misleading.
All the way back, I can remember the green. There was one little bitty 100,000 right in the middle.
Yeah, that's Manila.
It is Manila.
Yeah, we want to see it now that you've gone back.
I'm getting a sore thumb from doing it. I'm sure there was a smarter way. But thanks for coming on the journey.
It's sort of like a bait.
Oh, come on. There we go. Yes, you're right. So the only more recent geological map, as opposed to a metallogenic map, is Manila, sitting in here, and some maps that Jeff Brownlow did up on the coast. This is the Drake 100,000 map sheet that was sort of half done. Yeah, these have all been incorporated in the seamless. So with the metallogenic mapping, it wasn't necessarily a lot of enhancements to the geology. There were in places, but not always. A lot of the focus was on was documenting the mineral occurrences on those sheets.
So now that you're doing this sort of seamless stuff, is there any point in going back and doing map sheets again? I mean,
no.
If you're going to upgrade all these, enhance them, what do you just go in and do specific?
Yeah, exactly right. So East Riverina basically is there. Now, the historic approach in the survey was for every 100,000 map sheet area, and that was just a convenient size, was to put out a map and put out a volume of explanatory notes. Now, with East Riverina, we'll be just putting that line work straight into the seamless geology, and we'll be putting out a new release of the seamless geology. We'll probably end up doing a synthesis map. So geology of the East Riverina might be 500,000 scale, something like that. More of a wall, something you can put on the wall. It might actually be a themed map that's all about the magmatic history down there, because that's pretty important. In terms of explanatory notes, there's sort of no point putting out multiple volumes of explanatory notes that sort of describe the same belt of rocks, because they strike like this. So that's why we're moving towards these stratigraphic unit tables being updated, being available online, and then we'll be putting out synthesis papers and specialist papers on things that are of interest and importance.
Yeah, just on that, the Coonabarabran belt was handled pretty much that way. There's one big volume for the whole Coonabarabran belt.
Yeah, that's right. But it's already out of date. Every time we go out there, we find something new. And what do you do? So how do people find out that's now out of date because we've got a new age date from somewhere else, or we've realised we got something wrong. If that resource is available online, then it can be constantly updated and released. Yeah.
So Phil, with the geology data warehouse,
Yeah.
where it has individual outcrops and stuff, is there room there for citizen science? For people actually sending you messages and saying, hey, there's an outcrop down the back of my paddock and I think it looks really interesting.
Yeah, there is. We haven't got anything in progress to get that happen, but that's about as good as it gets. But it's fascinating when you go to somewhere like Henty and people they just know their land and they'll say, oh, yeah, I've got this funny rock up the back here, but we only get that interaction because we go to Henty. If you had something online, it would be really useful. So, it's a good idea, Joe. I think it's something something for your spare time. Yeah. Help us do.
Well, for instance, I know that Ray Biggs has been doing some fossicking around in his backyard.
Yeah.
And he does some really interesting stuff.
Yeah.
And,
He's got some basalts, I think, we've
he would love to
just analysed. Yeah. Yeah.
Especially fossils. Fossils are the things that
No,
throw
no.
most geologists. So
Yeah.
there was a way to send in a picture of a fossil and get a report on what it is later on.
Yeah, well, you can. We have like generic. Is it? I don't know. Barney might have even done the job in the past. What was it? Is it Bill the geologist, or you could email someone in the department? Wasn't you? No. It was Bill Chestnut, was it? Okay. Yeah. So yeah, but you can. I mean, you can go to one of our generic emails, I suppose, but we don't have, or someone you know, but we don't have a system set up for that. But yeah, it's a great idea. I think I'd like to see it.
So we actually have something a bit different. We have a emailed in question this evening.
Oh,
from somebody
wow.
that can't- Can you remind me of the gentleman's name, please?
Mark Hendricks.
Oh, okay.
Okay. So he asks the following. When the New South Wales survey will be infilling the missing airborne geophysical data in the New England fault belt and mapping the southern snowy mountains, it then further goes on to describe recent work in those sorts of areas and limited access to data, and summarizes by when can we expect geological information in these areas?
Right. Okay. Good question. There's an agenda there, so that's okay. I'm just trying to think what image I've got that's a bit better. But I don't know if you can see, but New England has the worst resolution geophysics, along with the Sydney Basin and along with Kosciuszko National Park, in terms of magnetics and gravity. So when we do magnetic surveys and radio elements get collected at the same time, we have an aircraft and it flies at between 40 and 80 metres height, and it flies along for whatever length of line, and then it does a U-turn and about 200 metres north or south, it comes back and then just does the same thing. Now, one of the problems with New England is you've got gorges and you've got a lot of changes in topography. So if you fly an aircraft, you suddenly you're that high, then suddenly you're that high, and it makes the data processing problematic. So the way to acquire that is by helicopter. If you do it by helicopter, I think it's about a 10, maybe 20-fold increase in the price. So that's why. When you also weigh up the fact that a lot of New England is World Heritage Area, and I guess ultimately, compared to somewhere like the Orange, Parks and Cobar areas and Broken Hill, has a lower prospectivity because a lot of our money does come from minerals and energy exploration. So if you factor in its high cost, low return for government expenditure, that's the reason for New England. Sydney Basin is similar. Imagine the outcry from Sydney residents if you've got a plane flying over at 40 metres, if you could get clearance for the airspace. And again, if the rationale was so, we could have a big, again, the prospectivity for metals isn't high, and it's pretty unlikely you're going to see a coal mine develop in the western suburbs.
Phil,
with Kosciuszko, we had planned to fly that area as part of our Southeast Lachlan survey that was done, I think, 2013. We couldn't get permission from national parks. Now, with gravity, it's a bit of a different story. With gravity, you either drive along roads and every couple of kilometres you get out and you put a gravitometer on the ground, and you step back and you take a reading and then you continue on, or you use a helicopter to do that. Now, a helicopter landing in a paddock when your sheep are lambing is obviously not good for anyone. Again, how do you land a helicopter in parts of New England where you've got World Heritage forests? So they're the reasons. I can email Mark back.
So data capture limitations.
Data capture limitations. One interesting thing with Kosciuszko is there's a lot of information that was collected with the Snowy hydro tunnelling schemes, and it's all sort of locked up at ANU is my understanding. But there's been a bit of talk. There's been a bit of talk with Snowy Hydro 2.0, as Malcolm likes to call it, of making sure we're in there. Somebody's in there as a geologist and recording what gets bored basically, and sampled.
I was just going to make a comment and a question, or two comments. About the 40-metre flight paths around Sydney. The military do this all the time with their bloody Black Hawk helicopters. I mean, I live on the edge of Sydney Harbour, and every other day the Black Hawks are flying down there just about that high off the water. Okay, so maybe you should talk to the military to get the clearance. Okay?
They could handle the complaints. That'd be great.
The second point is you are confusing time and rock terms here. At the risk of being a bit pedantic, you're talking about your pre-Cenozoic. It should be sub-Cenozoic. Okay. I've said at the risk of being pedantic, you are breaching the stratificative nomenclature here in talking and mixing, or at least in using time terms for rock terms.
Okay.
Comment.
Yep. No, taken.
One last question, and then we'll close it.
Yeah, just with your East Riverina project, I may have missed it, but are you doing much work on the Tumut Trough?
Not enough to understand the strain partitioning across the Gilmore Fault, if that makes any sense. So we're going about 10 k's east of the Gilmore Fault into the Tumut Trough, but it's not really about the Tumut Trough. Having said that, Mick Bell, who's at University of Newcastle, has been doing a fair bit of geochron work on trying to constrain deformation ages through the Tumut Trough. So there will be some new data coming out, which is sort of, it is a spin-off of East Riverina. Yeah. Hopefully, I think he finishes at the end of the year. So hopefully that data's out soon after that.
All right, that might do us for this evening. Thanks, Phil.
Good.